Welcome to this short video looking at how we can measure the rate of reaction. Over the course of this video, we'll look at how we can measure the rate of reaction and see how it is affected by changes in temperature. So let's have a quick look at some of the equipment we can use. So flasks are used to carry out reactions in. Gas syringes are used to measure the amount of gas produced very precisely. A stopwatch is used to time things in seconds. A balance measures the mass of reactants in grams or milligrams. A measuring cylinder is used to measure the amount of a liquid or a gas in milliliters. And a water bath is used to invert a measuring cylinder into, and then you fill it with water, and then you can measure the amount of gas produced by seeing how much water has been displaced. Thermometers are used to measure the temperature in degrees centigrade, and beakers are generally used to carry out reactions in, store things in, or mix or heat liquids in. So when thinking about practicals, there are several keywords that we need to remember. So a control variable is any variable which does not change during the experiment. The dependent variable is the variable that we are going to measure and responds to the independent variable. A hypothesis is a prediction on whether the independent variable will have an effect on the dependent variable. An independent variable is a variable that we are changing. An anomaly is a result that does not fit the pattern. A correlation is the relationship between two variables. An error is a measure of the difference between the measured and the calculated value and the true value. And precision and accuracy are often used interchangeably, but in science they have different meanings. So measurements that are close to the known value are said to be accurate, whereas measurements that are close to each other are said to be precise. Now that we've had a look at different variables and things, we can go and look at how we carry out the investigation. So remember, when you're putting a method together, it needs to be detailed. So let's have a look at how we can investigate how changing the temperature affects the rate of reaction. So the equipment that we can use is spread out on the desk below. So we might use a balance, some beakers, thermometers, and in this experiment we are going to measure the amount of gas produced using an inverted measuring cylinder. So we're going to start off, we're going to measure out 50 milliliters of hydrochloric acid and cool it to 5 degrees. Then using the balance, we're going to measure out around 20 grams of magnesium. We're going to pour both the acid and the magnesium into a flask. Then using an inverted measuring cylinder in a trough, we're going to set it up so that the amount of gas that's produced displaces water in the measuring cylinder, which can then be used to measure the amount of gas that is being produced. We're going to time it for 60 seconds, then we can go and work out the rate of reaction. So we're then going to go and repeat this with different temperatures. So 15 degrees, 25 degrees, and 35 degrees, for instance. We would also repeat each of those temperatures 3 times in order to go and get an average. So now that we've looked at how to carry out the investigation, there are just a few last things to think about. So there are a few questions that you should ask yourself when completing your method. So what thing should you do first? Is there something confusing you? And if there is, where could you look for some help? Could you explain your method to somebody else? So does it make sense? Could you have used more scientific terms within your method? And if you need help, do you know where to look for it? Have you double checked what you need to include? And have you had a think through how you could possibly make your method better? Right, that's it for now. Thanks for watching, and I hope this has been helpful.